Hey class, I wanted to help get you started with the graphing radical functions Dropbox assignment. I've selected number 2 from your document to work through together. So as you can see, our function is the square root of x minus 1 in the radical plus 3 outside of the radical. Remember that we are working off of a parent graph of y equals the square root of x. And when you make a table of values, an XY table, it's really convenient for you to select perfect squares for x, such as 0, 1, 4, 9, 16, and so forth. Because then when you go to take the square root of all of those values, you will end up with a whole number. So the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, and the square root of 16 is 4. And so these are kind of our parent graph shapes. Now, we have transformations occurring here, which is why we have the minus 1 inside the radical and the plus 3 that's outside of the radical. And so what I'm going to do is take this table of values and adjust them by those two transformations. So the minus 1 is a horizontal shift, and horizontal things always do the backwards of what your mind wants to think. That's actually going to move us right 1. So I am going to change all of these x values by adding 1 to them to show that they are shifting right 1. And then for my y values, because of the plus 3, that's a vertical shift. And the verticals go the direction that you would think with the signs. So this is going to move us up 3. And so I will add 3 to all of these y points, and I will end up with some nice whole number ordered pairs of 1, 3, 2, 4, 5, 5. This is just by adding the values in blue and in red. This is 10, 6. And the last one would be 17, 7. So I'm going to go ahead and plot those points. 1, 3 is one of them. 2, 4 is the next one. 5, 5. 10, 6. And then way out here I would put like a 17, 7. Kind of beyond my graph. Okay, so a little bit about square root graphs is that they are the inverse of a parabola. And so what they really represent is a sideways parabola that's been cut in half. So if you were to take this parabola on its side and only take the top half of it, like if you reflected it 90 degrees, that is the shape of a square root graph. So hopefully you're going to notice that your domain is impacted by that. So for the interval of increase, what I like to do is follow my finger along my graph from left to right. And as long as my finger is going up, then that means that it is increasing. So for this one, our interval of increase is from 1 to infinity. And the reason why I say 1 and not negative infinity, like all real numbers, is because there are not going to be any points to the left of 1. Because if we had used something smaller than 1, that meant that on the parent graph we would have had to use something smaller than 0. And you cannot take square roots of negative numbers, they are imaginary. So 0 is the smallest value I can put inside of the parent graph function. And then when I make my adjustment for the transformation, that's as small as I'm going to be. So it has to start at 1. That also affects our domain, that it goes from 1 to positive infinity, all of our x's on the right, okay? There is no interval of decrease here because my finger along my graph was never decreasing or going down, so there's none. Then you could just transfer these 5 points that we have here into the XY table. For the range, you're based off of the Y values, and you want to ask yourself, what Y values does this use and can it use, and which ones is it never going to use? And so because the parent function had its lowest Y value at 0, a square root, we're never going to give an output of a negative number. We never say the square root of 4 is -2. So 0 is the smallest in my blue Y values. But then because of the +3 moving us up 3 becomes our smallest Y value. So from 3 to infinity, because it's increasing, its Y values will continue to go upward, is our range. As you can see here, we do not have an x-intercept or a y-intercept. I do want to show you how you could calculate those if you kind of can tell that you have an x-intercept, but you don't know exactly where it is. X-intercept is when y is 0. And so you would take your equation and set the y equal to 0, and then you would solve for x by moving over the outside terms and then squaring both sides because we have a square root, and then adding 1, adding 1. That would give us an x-intercept if we had one, but we don't here. That's the process for finding one. And then for the y-intercept, what you would want to do is just sub in 0 and where the x is, and then evaluate to get your y value. So we'd have y equals the square root of 0 minus 1 inside the radical plus 3. You can see why this is not giving us a y-intercept, because we would have an imaginary -1 in the radical, which is I, and so that's why we're not getting a y-intercept here. So that's kind of your answers for number 2. I hope it helps you work through the rest of the assignment.